Hi everyone, in this video lesson you will learn about polynomials and zeros of polynomials. Okay, so before I do any of that, if you have a single solution or single root, it's going to be that's a linear, right? It's going to behave like a line. So when it crosses the x-axis, it's going to cut right through it. So for example, this point, as this graph crosses the x-axis, as you can see, cuts through that point, and also this one, it cuts through that point. And then what if you have 3 points and they're all singles? So then cuts through this point, and cuts through that point. Okay, so they behave like lines. What about double? If you have a double root, so if you have a double root, which means the solution repeats, then you see the graph bouncing off of the x-axis at that point. So that'll show it to, that'll be like a vertex of a parabola. So for example, here you have the parabola hits that point, okay, and bounces right off of it. Another example, this one has 2 solutions, 3 solutions, bounces off of this point and then cuts through the other point. And the last one is a triple solution. Okay, so the solutions look like the graph flattens at the x-axis, so we call that a slide. So as you can see, this graph gets to that point and then slides through it, doesn't cut, doesn't bounce, just slides through that point. And the same thing here, gets here and then goes flat and then passes through that point and again flattens again and continues going down. So anyways, the idea of this is to help you without even graphing exactly or precisely the graph, you can determine how the graph behaves. Okay, so this is the behavior of polynomial graphs at different types of solutions, single, doubles, or triples. So we call these solutions that they have multiplicities. So I'm going to write that here. So it's either multiplicity of 2 or 3 or more. Okay, so it's just multiplicities there. One, we just say it's a single solution. So for example, we're being asked to find the zeros of each function and then say multiplicities and sketch the graph. So for this one, if I multiply this x times this x, I shouldn't write equal here. So x times x is going to become x squared. But then we have a negative lead. So that means the graph, since the degree is even, the graph should be pointing in the same direction. Both ends should be pointing in the same direction. That's on the lesson. The previous lesson covered that. Okay, so then I know that if I set x plus 1 equal to 0 and x minus 3 equal to 0, then solutions are x equals negative 1 for this one and x equals positive 3 for this one. So when I sketch the graph, I need to keep in mind that the lead coefficient is negative, right? So then we have an intersection at x equals negative 1, and 1, 2, and 3, another intersection at x equals 3. So a point of intersection here and here. Since we have a negative lead, then the graph will be pointing down. So it's going to pass through this point, cut through it, then turn and cut through this point, and this is what the graph will look like for this polynomial. Okay, so that's the first example. Example number 2. I have a negative lead again, and I have x times x times x, so the end result is going to be negative x to the third. Since the power is odd, that means the ends will point in the opposite direction. So one side, the right side points down, and the left side is going to point up, okay, because the degree is odd. So keep that in mind. So I set negative x equals 0, and then I have x plus 2 equals 0, and x minus 2 equals 0. So when I solve for this one, divide by negative 1. So x equals 0 is one solution. This one subtract 2, so x equals negative 2. And this one here, x equals positive 2. So then I notice that these are all single solutions. So I'm going to sketch the graph. Again, this is a rough sketch, not precise. Okay, just to get a visual here. So let's say this is negative 2, and this is negative 1. This is positive 1, and this is positive 2. So then we have intersections at x equals negative 2, at x equals 0, and at x equals positive 2. So then, as we said, the right-hand behavior is down because the lead coefficient is negative, and then that means this one should be going up. And they're all cuts. So it's going to cut through this point, it's going to cut through the origin, and it's going to cut through x equals 2. So that's what the graph looks like for this problem. Okay, example number 3. For this one, I set each one of them equal to 0. So x plus 6 equals 0, and x plus 4 equals 0. So then subtract 6 for this one, which means x equals negative 6. And for this one, x equals negative 4. But notice this is second power. So this one here is a double solution. So that'll tell us that it's going to bounce right off of the x-axis. So then let's sketch the x and the y-axis. So we need more of the negative values. So let's say this is negative 1, 2, 3, 4, negative 4, negative 5, negative 6. Okay, so we have for this one at negative 6, there's one intersection, and at negative 4 is the other intersection. So then for this one, when we graph it, we know that this is a positive lead coefficient, and when you multiply the second times the first, we end up with x to the third. So the power or the degree is odd, so that means the end's going opposite directions. Since there's a negative lead, that means the right hand behavior is up and the left hand behavior is down, right? But at negative 6, we'll see a bounce. So it's going to hit that point and bounce right off of it, then turn and go back up and pass through that point. So this is what that graph looks like. Okay, example number 4. For this one, if I set x plus 1 equals 0 and x plus 5 equals 0, I subtract 1, so x equals negative 1, and I subtract 5 here, so x equals negative 5. Now notice this is multiplicity of 3, so that means this is a triple solution. So it's going to slide through that point. If I multiply x to the third times x to the first, I end up with x to the fourth. So the degree is even, so that means the ends point in the same direction. So then this will behave like a parabola in the ends. So when I sketch the graph, let me show you what graph looks like for this problem. Okay, so we need, let's see, negative 1, negative 2, negative 3, negative 4, and negative 5. So we have an intersection here at x equals negative 5 and 1 at x equals negative 1. So then since x equal to negative 1, we should be able to see the graph sliding through that point. Okay, so at negative 5 it's a single, so it's going to cut through it, and the ends point in the same direction because we do not, since we do not have a negative lead, then both ends should be pointing up. So it's going to come through this point, cut through it, and then turns to this point and slides through that point, and then continues going up. I'm a little bit off on this part here, but I hope you understand the idea. Okay, this point should be a slide, not a cut, not a bounce. All right, so that's example number 4. What about the next few examples? In this case, we need to write the polynomial function in standard form with the given zeros. So for the next part, I just copied this. Since this is x equals negative 2, then it should be plus 2 here. Since this is x equals 1, it should be minus 1 in here. And since this is 4, it should be minus 4. Okay, so I need to expand. And what I'm going to do is I'm going to expand these two terms first by multiplying the terms together. So x times x is x squared. X times negative 1, that's negative 1x. 2 times x, positive 2x. 2x minus 1x, 1x, right? And then 2 times negative 1, that's negative 2. And then we still need to multiply this term by, this trinomial by x minus 4. So x to the second times x to the first, that is x to the third. X to the second times negative 4, that's negative 4x squared. And then x times x plus x squared. X times negative 4, that's negative 4x. And then we have negative 2 times x, that's negative 2x. Negative 2 times negative 4, that's positive 8. Okay, so then combine like terms to simplify. So we have x to the third, x to the second, 4 negatives of them, and 1 positive. So minus 3x to the second. And then we have negative 4x minus 2x, that's minus 6x, and then the plus 8. So this is the polynomial that has those solutions. So once I write the polynomial in factor form, what I'm going to do is I'm going to multiply. I'm going to start with these two terms first. I'm going to bring this x to the front. So y equals x times x times x is x squared. X times 1, 1x, but then 1 times x, they combine to 2 x's, and 1 times 1 is 1. And then we have x minus 2. So now I'm going to multiply this trinomial with this binomial, and I'll do this one last. So then y equals, keep the x outside, x to the second times x to the first is x to the third. X to the second times negative 2, negative 2x to the second. Then next is 2x times x plus 2x to the second. 2x times negative 4, negative 2, negative 4x. And then 1 times x, positive x. 1 times negative 2, negative 2. So here, I'm going to combine like terms, and in the end, I'm going to multiply by x. So y equals x times x to the third. These negative 2x's and those positive 2x's cancel out. So then we have negative 4x plus x minus 3x, and then minus 2. So last, I'm going to distribute this x. So x times x to the third is x to the fourth. X times negative 3x, that's what, negative 3x squared. And then x times negative 2, that's negative 2x. So this is the polynomial that has those given solutions. Okay? So one last example. So for this one here, if this is minus 2, that means inside of a parentheses, it has to be x plus 2. If it's 0, then this is just x. We have two of them. So that's a double solution. And the last one is x minus 3 because it's a positive 3. Okay? So what I'm going to do is I'm going to multiply these two together and bring them to the front. So y equals x squared multiplying x times x, and then x plus 2 times x minus 3. So what I'm going to do next is I'm going to multiply these two binomials. So y equals, keep this one on the front, x times x, x squared, x times negative 3, that's negative 3x. 2 times x, that's positive 2x, so then minus x. And then last is 2 times negative 3, which is minus 6. Okay, then we distribute. So I have y equals x times x, x to the second times x to the second is x to the fourth. And minus x to the second times x to the first, that's x to the third. And x to the second times negative 6. That's negative 6x to the second, and this is the polynomial that has those given solutions.